add. For example, joule heating can be utilized. For example, in induction furnace, which is a very cool thing if you think about it, that they figured that out. That there is a container in which there is metal, let's say in a steel plant. So there is a metal here. Whatever. So it will become molten after joule heating. So basically, if you have seen the photos or videos of molten metal, it's usually lava, like it's orange color, right? So when it's basically lot of, but I haven't told you how exactly it happens, but what happens is essentially the metal inside gets heated up a lot. It heats up so much that it starts melting, and finally you have fluid metal inside the furnace. So this portion here, which is probably some other metal which has a higher melting point, okay, or some material which has a higher melting point. It doesn't have to be a metal. It should be allowing the magnetic field to pass through. That's the thing. So basically, the molten, the metal is now inside, and now that you use for whatever you want to purify the metal, and then later you want to get steel out of it, or what you melt metals in metallurgy, right? So that's how you do it. You can use other ways to melt metal, but this is one of the ways which I find very cool. So, and this is the same thing that happens here. There, though, you're not moving the whole thing. That's less efficient or practical than actually using a what you call a large magnetic field. And it's not a bar magnet, so I'm not gonna assume it's a bar magnet. You just have a magnetic field which essentially so the magnetic field can vary